says compute the mean and standard deviation using the methods in this section. Now, I have, let me pull it off your formula sheet. I'll write it bigger so that you can see it. But off of your formula sheet, it says mean and standard deviation of a binomial random variable. So it says NP square root of NP 1 minus P. Okay? So this is going to be our mean. This is going to be our standard deviation. And that's from the formula sheet. So we have our N and we have our P. So we could, and remember P is going to be our successes. So if we want to know our failures, we're going to do 1 minus P. So if P is 0.5, 1 minus 0.5 is going to be 0.5. We good? So to get my mean, I'm going to do N times P. So what is my N? 8. And what is my P? 0.5. So I go to my calculator and I do 8 times 0.5. So my mean is going to be 4. We good with that one? Now, for my standard deviation, it's going to be the square root of N times P times 1 minus P. Well, N, we said was 8. P, we said was 0.5. And 1 minus P is 1 minus 0.5, which is 0.5. So when I go to my calculator, I'm going to do the square root of 8 times 0.5 times 0.5. And that's going to give me my standard deviation, is 1.414. That's my standard deviation. And then right below is going to be the pretty version of what I just did. Scooch this down a little bit so we can have a little bit of room. All right, so let me let you do one.
Well, hold on real quick.
Yeah.
Just looking at that formula underneath that square root, why didn't we do 1 minus 0.5?
I did. I actually did it over here. 1 minus 0.5
Okay.
is 0.5.
Okay. I'm just confused because it says NP. Oh, because N times P. Never mind. I'm not confused
Yeah.
anymore.
But I could have just as easily written it as 8 times 0.5 times 1 minus 0.5. I could have written it like that as well.
Okay.
You could have also just taken the results of NMP from the first part and put that instead of 8 times 0.5.
So I could have just taken 4, which is N times P, and multiplied it by 1 minus 0.5. Or I could have just taken 4 and multiplied it by 0.5.
Just however you want to plug it in, just as long as
Uh-huh.
you're plugging in the right stuff. Okay.
So for this one, our two formulas are going to be that the mean is N times P, and that the standard deviation is N times P times 1 minus P. So however you want to do it, I just want to know the mean and the standard deviation. So whatever floats your boat. They did the standard deviation to 1 decimal point. All right, so my N times P is gonna be 10 times 0.2, which is 5. That's gonna be my mean. Now, my standard deviation, I can do 10 times 0.2 times 1 minus 0.2, or I can say 5 times 0.8 and do the square root of that. Yes, boo?
For 10?
Oh, that's not right, is it? I'm doing 10 times 0.5. It is gonna be 4? No, 2.
Yeah.
Thank you. And then, I don't know why I was doing half of 10. And then the standard deviation should be 1.3 if we round it to one place behind the decimal. And you don't have to simplify it like that. You can just type it straight into your calculator. You can say, I want to do the square root of 10 times 0.2 parentheses 1 minus 0.2, close it. There would be my answer. Are we good? And then down here is my, and then instead of doing the 1 minus P, and this was the shortcut I think that Austin was talking about, instead of doing the N times P, they took the answer from N and P, and you could plug that in, so they could call that 2. And 1 minus P, which are your failures, 1 minus 0.2 is 0.8. So you could have done 2 times 0.8 up underneath, instead of plugging in all of them again. So you could have done the square root of 2 times 0.8. Yay? Does not matter. All right, let's look at number 37, flushing a toilet. Get this down just a hair. In a survey, it was found that 64% of Americans operate the flusher of toilets with their foot. Suppose a random sample of n equals 20 is obtained and the number of X who flush public toilets with their foot is recorded. Find and interpret the probability that exactly 12 flush public toilets with their foot. So after you potty, do you karate chop it. So our probability, our P, is going to be our percent, 64%. So they went ahead and said if this is the successes, our failures are going to be 36. Okay? And then N is our sample size. So the only thing that we're missing is our X. So to get our X, we're going to look right here. X and 12.
So X equals 12.
Exactly means it's going to equal. So if we come over to the rules, X equals 12 means we're going to do what?
PDF.
The PDF. So from our rules, X equal 12 means we're going to do the binomial PDF. And what order do they go?
NPX.
NPX, because they're in ABC order. So what is my N?
20.
20. What is my P?
0.64.
0.64. And what is my X? 12. So I go to my calculator. I'm going to do second bars. Going to go down to NP, binomial NPF. And I'm going to do 20.64 and 12. Oh, I changed the mode and forgot to change it back on the break. Put it in classic mode so that it will wrap around. There we go. So, there is, the equal means that we're doing the PDF, and so it's gonna be 0.1678 is gonna be my answer. Good for the first one? All right, same problem, but this time we're doing at least 16 flushes. So, this is gonna be my X. So, what does at least mean? If you have at least $16 in your pocket,
Greater than or equal
you have $16 or more. So that means that you could have more than $16 or you could have exactly $16. So we've got to think about our rule. What is the greater than or equal to 16 rule?
X minus 1,
X minus 1 and
1 minus CDF.
okay? So that means we have to take 1 away from the X. So what is my X going to become?
15.
15. Then we're going to do 1 minus the binomial CDF of N, P, and X. So what is my N?
20.
20. What is my P? 0.64. And what is my X? 15, because I changed it. So when I go in my calculator, I'm going to do the 1 minus the binomial of the CDF of blah, 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 blah. And when I type that in, that is what I should get. Again, knowing those rules. And now being able to read the problem and know what sign goes there. And in my head, I've got to say, how much money do I have? All right, this one's a little bit tricky. We have not done one like this before. What's the probability that they have between 9 and 11 inclusively? What does inclusively mean? Does it include 9 and 11, or does it not include 9 and 11?
It includes.
It includes 9 and 11. So, between 9 and 11 inclusively, that's going to help us determine our X. So, our X is between 9 and 11. Inclusively means that it includes 9 and 11. So, you're going to have that equal to. So, X is what to 11?
Well, less
Less than or equal to. X is what to 9?
Greater than.
Greater than or equal to. So, that's what it's going to look like. Now, I'm going to split that up and say that X is less than or equal to 11, and I'm going to say that X is greater than or equal to 9. I like to have my X first because when I did all my rules, my X was first. So I left this one the way it was because X was first. But for this one, it's like I put it on a piece of transparent paper and flipped it. And when I flipped it, this flipped. You with me? So when I put X first, this had to put, so when I flipped it over, that had to flip over. Okay? So, let me grab a set of rules so that we can look at them for a second. Copy. Move them up so I can have a and that one. So, for the first rule, it's gonna be this one, which is a straight out binomial CDF. So for the first one, we're gonna do a binomial CDF of NPX. What's my N? 20, what's my P? 0.64, what's my X? 11. Is everybody good with that one? Yay? Now, when I go to do this one, that's a greater than or equal to, which is going to be this one. This one, we have to subtract 1 from my X. So what is my X going to become?
10.
8, because we're now looking at that second one. Now, you know how in English there's always an exception to the rule? You know, you do this 99% of the time. We subtracted 1 from the rule, but now it says subtract 1. This is like your 1. When it's a between, this is like your 1. So you're not going to do 1 minus. You're going to do this minus. Because it's a between.
How do you do that?
So you're going to do minus the binomial of, let's see if I can make all this down at the same time. Oh, crap, I didn't notice. Okay, this went with greater than, no, yes, that one went there, that one went there, that one went there, that goes away, that goes away. Okay, so this is gonna be the binomial of N is still 20, that's still 0.64, and that's gonna be 8. So you're not gonna do the 1 minus because you're minusing it from this because it's a between. Don't do 1 minus because it is a between. So I can do one of two things. I can either find this answer and subtract them, or I can type that whole thing in at once. Making sure that I close that parentheses, because if I don't, it's going to be inside that binomial CDF. So I can do it all in one step if I want to. So if I come up here, I'm going to do second vars, binomial CDF. Comma, 0.64, comma, 11, close that problem, and then subtract the other binomial CDF. And the reason we're subtracting is because we're trying to find the distance between. And we're doing another 20, comma, 0.64, but this time it's going to be 8 because they told us we had to subtract 1. So there's my answer. And then there's the other explanation. A little bit prettier than mine. All right, let's look at the next one. would it be unusual? Would it be unusual to find more than 17 who flush public toilets with their feet? Or with their foot? More than 17. More than 17. How do you write more than 17? Greater than 17. So on our rules, what does x greater than 17 or x greater than a number mean? 1 minus the binomial CDF. So we're going to do 1 minus NPX. So what is my N?
20.64.
My P? My X?
17.
I didn't write the word, did I? 1 minus the binomial CDF. I would type that in my calculator, and I would get my answer. Is it unusual?
Yes,
Why?
because it's less than 0.05.
Correct. All right, let's let you try one. This is talking about Clarinex, which is like Claritin. Clarinex reduces symptoms associated with allergies. 5% of the patients had insomnia. A random sample of 20 users, the number of patients who experienced, find the probability that exactly 3 experienced insomnia. Good. 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 All right, what is my N in this problem? 20. I asked 20 people. What is my P? 0.05. That's my percentage. What is my X? Exactly 3 is going to be X equals 3. So in my rules, I've got to go make sure I write them down. In my rules, X equals 3. What does my rule say? Normal PDF. So I'm going to do, or the binomial, normal, the binomial, whatever. PDF of N, P, and X. So it's gonna be 20, 0.05, and 3. And when I type that into my calculator, that should have been your answer. Good? Now, we're still using the fact that we surveyed 20 people and there's a 5% success rate. Okay? 20 people with a 5% success rate. I would like you to do this one now. N equals 20, P equals 0.05. 3 or fewer. 3 or fewer. Automatically gonna miss 2 questions if you come into the test and do not write these rules down. How do we write 3 or fewer?
Less than or equal to.
X is less than or equal to 3. And then in our rules, we have to know X is less than or equal to 3 is going to be which rule?
Binomial CDF.
A plain binomial CDF of N, P, and X. So we're going to do a binomial CDF of 20, 0.05, and 3. And when I type that in my calculator, there's my answer. All right. A little bit harder. Between 1 and 4 patients inclusively. Between 1 and 4 patients inclusively. We still know that our sample is 20 and our P is 0.05. Between 1 and 4 patients inclusively.